Hello everyone, and welcome back to Weather with Ryan. Today, I'd like to discuss something that you may not have thought about before. Just how tall are thunderstorms? One of my favorite aspects of flying is looking at the clouds out the window. One of my all-time favorite flights was a short one from Washington Reagan to Syracuse late one evening. By the time we reached cruising altitude, the western sky was dark, and all the light that could be seen in the distance was from lightning from a towering thunderstorm somewhere off to our west. It was a beautiful display of nature's power, weaving and dancing throughout the nighttime sky. Perhaps you've witnessed this same phenomena, or maybe you've been on a summer afternoon flight and saw a towering cloud off in the distance. Regardless, was that abnormal, or was that typical? Are thunderstorms and commercial aircraft high-flying friends, or occasional passerbys? Before we discuss how tall a thunderstorm is, we should establish what is a thunderstorm. Well, a thunderstorm, by definition, is a storm that is always accompanied by lightning and thunder that is produced by a cumulonimbus cloud. The first part of this definition is rather easily understood by our everyday experiences and by the name thunderstorm, but the second half, about their type of cloud, is not so easily understood. What is a cumulonimbus cloud? This is equally as important to the definition as all thunderstorms are cumulonimbus clouds, regardless of their type. To help us understand this type of cloud, I'd like to start by looking at the National Weather Service's cloud chart. There are 27 cloud types listed on this chart, classified by their height and their appearance. A video dedicated to cloud classification is planned, so we'll discuss the details later. Clouds are first classified by their height, either low, middle, or high. They are then classified by what they look like, and we combine the two names. For example, we use the prefix cirro for high clouds, followed by the suffix cumulus for clouds with vertical growth. Combining these two names, we get cirrocumulus, or clouds that are high in the atmosphere that have vertical growth. These appear in the upper right corner of our chart. Now that we know how clouds are classified, let's break down cumulonimbus into its two roots, cumulo and nimbus. From our previous example, we know that cumulo is used to describe clouds that have vertical growth, and nimbus is the Latin word for rain. Therefore, combining the two, we get a cloud that has vertical growth and produces rain. Looking at the chart, we find this in the bottom right corner. As viewed from a distance, cumulonimbus clouds have a very characteristic and easily recognizable appearance. They are massive clouds that look like a large anvil. You might better know an anvil as the large metal object that is dropped on cartoon characters, like the one being dropped on Wile here by Roadrunner. The lower level of the clouds often resemble cauliflower or heads of broccoli. The top half is very flat and often fibrous looking and is like a lid. This is known as the anvil, and why they are sometimes referred to as anvil clouds. You might also notice a dome overshooting the anvil. This is known as the overshooting top, and this is where the air is being forced upward very quickly inside the cloud. Now that we know the structure of these massive clouds, let's look at how they compare to other clouds. Given their location on the chart, we might be mistaken in thinking that they are low-level clouds, but they are not. They begin at the low levels, but they quickly grow to be very tall, spanning the entire depth of the lower layer of the atmosphere, called the troposphere. It's not uncommon for a variety of other clouds to be present around a cumulonimbus cloud, given their giant nature and their vertical extent. At this point, you might be thinking that low, middle, and high clouds are very vague, and that I haven't really answered the question yet. And to answer this question of how tall are thunderstorms, let's take a look at two real-world examples of thunderstorms. The first occurred the evening of June 13th around 7 p.m. Central Daylight Time, or CDT. This visible satellite image was taken at 23Z, June 13th, or 6 p.m. CDT. Thunderstorms appear as areas that are bumpy and thick when using visible imagery. Looking throughout the Great Lakes region, we can see multiple thunderstorms, one over eastern Lake Michigan, one over the city of Chicago, and a group of storms in southern Ohio. This next image shows the same satellite image, but has echo tops or cloud height overlaid in the shaded color, with the lighter colors corresponding to higher heights and the darker colors corresponding to lower heights. The labeled numbers are in hundreds of feet, so a label of 400 is 40,000 feet. Of the three storms mentioned previously, the storm over Chicago was the tallest at 69,000 feet, followed by the storm over Lake Michigan at 61,000 feet, and finally by the group of storms in southern Ohio, with the tallest at 59,000 feet. Viewing these same storms again an hour later, we see that the storm over Chicago now has a much larger anvil that's way broader than before. The overshooting top is also visible along the coastline near Chicago of that storm. We also see that the other two storms have grown in size as well. Once again, switching to cloud height, we see that these storms are now all over 60,000 feet tall. You might notice that there is a discontinuity on the right side of your screen. This is the terminator, or the line that separates day and night. Visible imagery cannot be used at night, so the software is showing where the visible image ends and the infrared image begins, since we can use infrared imagery at night. Focusing on the storm in Chicago, we would classify this as a severe thunderstorm, as it produced tornadoes as well as quarter-sized hail, both of which are criteria for a storm to reach severe status. This storm also produced a wind gust of 84 miles per hour, which was recorded at Chicago O'Hare International Airport, which also falls in the category of severe storms, but more on that in a future video. The second example takes us to Florida, the state with the greatest number of thunderstorms. Looking at this visible satellite image from June 20th, 2022 at 1921Z or 3:21 Eastern Daylight Time, we see widespread thunderstorms across the state. There are much smaller storms than the storms from our first example, as they are ordinary thunderstorms, also known as garden variety thunderstorms. These are almost a daily occurrence during the summer in Florida. Overlaying echo tops, we see that most of these thunderstorms are below 50,000 feet, but the tallest is 60,000 feet, and there are other storms that are above 50,000 feet. This serves as a good example of how there is no one answer when it comes to thunderstorm height, as each storm is slightly different, and the type of thunderstorm doesn't necessarily determine its height. Finally, I've once again utilized my finest PowerPoint skills to create this comparison schematic between cumulonimbus clouds and some other well-known objects. Based on the real-world storms we looked at previously, I assume the anvil of our thunderstorms is roughly at 50,000 feet, which is typical for a thunderstorm in the United States during the summer, and the base is at 2,500 feet, also typical for a rather humid environment. First, let's compare this to the tallest building in the Western Hemisphere, One World Trade Center in New York City, which sits at 1,776 feet tall. Compared to our storm, it's barely noticeable. In fact, it's probably slightly too tall in my schematic, but it was too hard to see if it were any smaller. Second, let's look at our typical summer afternoon fair weather cumulus cloud. These typically resemble cotton balls and have an average height of about 3,500 feet, although this varies depending on the temperature and the humidity. Regardless, they are still much shorter than our cumulonimbus. Next, let's compare the tallest mountain in the world, Mount Everest, which is a bit taller than 29,000 feet, or about 60% of the height of our thunderstorm. Last, let's look at a typical commercial passenger jet. A typical commercial flight is operated at 38,000 feet, which is still below a tall thunderstorm. This is primarily why thunderstorms are so disruptive to air travel. Because thunderstorms are so incredibly tall, planes cannot fly over them and must go around them, which places pressure on the national air traffic system. But the other issue is when these storms occur near airports, they threaten airport operations from a safety standpoint due to lightning and potentially hail and tornadoes and heavy rain and even wind and other issues associated with thunderstorms, but they also disrupt aircraft operations as they block off entrances and exit paths to the airport for incoming and outgoing planes. With that, we finally answered the question, how tall are thunderstorms? And like most things pertaining to the weather, the answer is, it depends. Thunderstorm height is dependent on many things, like the season or the latitude you're at, just to name a few. They can range from 27,000 feet in the higher latitudes to well over 60,000 feet in the tropical latitudes. But here in the US during the summer months, they have an average height of about 50,000 feet. And if you made it this far to the video, I really like to thank you. If you enjoyed it or learned something, consider giving it a thumbs up, and if you aren't subscribing yet, consider hitting that subscribe button. And until next time, keep looking at the sky. Did anyone notice that I was saying cumulonimbus really weirdly throughout this video? No? Just me? Oops.